Okay, so I'm going to present today a longitudinal study that is a work we are trying to do with the Biomarker of Aging Consortium, which is basically try to identify and actually establish the first cohort of like volunteer to collect multi-omics data that we can use to build like longitudinal studies. Now, before start, I just want to spend a few words on this topic that has been touched extensively during this day, but I think it's important because one of the biggest challenges in the field, I think, is give a proper definition to the word aging. Because if we look on like online, it's not very helpful, since aging is defined like the process of being older. And even if every one of us is it's able to discriminate in this picture with the old and with the young person, defining aging is very challenging because aging is not a disease per se with a clear phenotype. Sometimes it's defined as the predisposition to a disease. So many people try to address this question, and I mean, the definition that I like personally the most is loss of resilience, loss of elasticity, due to time, of course, and environment-dependent accumulation of cellular damage. So this definition led to the definition of chronological and biological age, which I mean are two different concepts, because as you know, chronological age is just a number, is a measure of time, while biological age is actually the goal of biological age, is trying to identify how much damage has occurred in our body during a certain amount of time. So this implies that people age differently, as we can see from this picture, and despite people can have the same chronological age, depending on how much cellular damage has occurred, two individuals can have a very different biological age. And as also Mike this morning extensively described, if we take genetics out of the game, which is the most important factors, the environment plays a pivotal role. And I would say most of the fun things to do are actually unhealthy for our life. So sometimes it's also a compromise between what make us happy and what make us healthy. But by the way, so there are several challenges in the biological biomarker aging development, because measuring aging thanks to the biomarker can actually lead, it can actually help us to identify, first of all, health outcome, but also to evaluate rejuvenation intervention, because one of the major problems in the field is the inability of having a reliable way to measure if a rejuvenation intervention is working or not. And I mean, as Vadim touched all this point before, so the challenge in the biomarker rely on the fact that basically we still have a unique and clear definition of aging. Also, that different cell and different organ, they have a different pace in aging. Sometimes also the different organ and system interact together. So this makes also the complex even more complicated. And I would say least but not last, the individual variability and the absence of data set that we can use to train this fancy machine learning method to actually measure biological age. And I like this example that I think is pretty understandable. So the reason why I think aging is difficult to measure is because it's a background phenotype. So a disease has a very clear phenotype. Aging is something extremely differentiated from the background, but extremely close. And that's why developing a reliable biomarker is essentially is the key. Now, which biomarker is the best? I think that multi-omics is probably the best way to address, because epigenomics, of course, is important, but in the plasma, we have also the product of different organs. So combining different molecular markers, it's probably the best way to develop strong biomarker in the field. So, and this is just a nice example that I use to explain what I think, because again, if you single assay, as it was done in the past, it's very difficult to understand what's going on. So using a single omic approach can give us more information, but actually only if we develop multi-omics, try to understand aging in its complexity by using different approach, we can actually have a clear picture of what is actually happening during aging. Okay, so in order to address these challenges, a couple of years ago, Madi and other people founded the Biomarker of Aging Consortium, and the goal of the consortium is bring together experts in the field, first of all, to reach a consensus in the definition, which again, sometimes are not very unique, and at the same time also to set guideline and to promote the development of biomarkers that can be actually used to measure biological age effectively. And I don't have time, but there are several initiatives. One of them is BioLearn, that is an open source that contains a lot of data that people can easily access and they can use to develop and to test their biomarker. There is also a challenge which is ongoing. We're in phase 2 now, and the goal is to promote people to develop new methods to estimate biological age, mortality, and multimorbidity. There are 3 different tasks. But what we realized during this competition and initiative is that in the field, a cohort is actually missing. So there is not actually a data set that is able to be used to properly measure and to properly estimate biological age. And to fill this gap, there's this initiative between Harvard and Stanford. So the goal is basically to collect and to develop the first cohort of multi-omics by enrolling people at the conference. So the format is basically we will give free access to the conference to the people that are willing to donate their blood. There is going to be a questionnaire self-submitted where people will answer information about nutrition, exercise, and health status. Then we will collect blood and hopefully other maybe some swab. We're still trying to figure out which is the best way and the logistic. And the goal is basically to take the blood and to collect the blood in order to be able to run epigenomics, transcriptomics, proteomics, and metabolomics. And the good thing of this study, first of all, is that the data are going to be shared, and the collection will happen in the same day by the same group of people. So the variability is going to be contained, and the goal is try to repeat this process every year for 10 years in order to collect actually a longitudinal map and a longitudinal study that will have information about the same people over time. So if you guys are interested, this is the conference is going to happen in November in Boston, in Harvard. If you want to sign up, if you didn't have already, and if you want your blood to be taken and biomarker to be analyzed, it's a good occasion. And we're going to release, of course, the data publicly, but only the person is going to be know the code, so it's going to know which are their sample. And I think that's it. Of course, I want to thank Mike, Vadim, and Vittorio, Andrea, Meyer, Verdin, which are the scientific steering committee. Of course, Madi, that was the person who started everything, the amazing team, which is the executive committee, and I'm happy to take questions. Thank you.
All right. I'll just ask one quick question, which is, what about extracellular damage? You mentioned cellular damage, but are you guys going to look at extracellular damage at all?
I mean, that's a good point. The limitation of the study is that we cannot control for people lifestyle. So the only way that we are going to have to control these people is the questionnaire. Mm-hmm. So basically we are going to collect biomarker, and the goal is to understand if major life change stuff will happen. So we hope to have also a very heterogeneous age representation in the conference, people with disease. So our goal is to try to understand if there is major challenges. This extracellular damage is something that I don't know if we'll be able to measure with this state. Yes.
Do you have thoughts on distinguishing between adaptive responses to damage and damage itself? Because aging is a stressful process, and many of the things we associate with aging and damage are adaptive responses to damage. So do you have thoughts on that?
No, that's a great point. So I'm biased because I think aging is mostly epigenetics. But there are several, epigenetics, adaptation, and aging are 3 concepts very close between each other. There was a very nice example that is actually one of the review that Vadim wrote. It's about the bees. So they say that epigenetics is actually the mechanism that decides the lifespans on the bees. The queen, they live 9 times more than the worker bees, no? And it's basically epigenetics, so the mechanism that is regulating this lifestyle. So I would say aging, in my mind, is the result of adaptive events that are happening during our life. And that's why the resilience is the capability of adaptation. So I think the more we adapt and the more we accumulate these epigenetic marks, we will reach a point where probably the entropy is going to be higher than the actual adaptation, and that's probably, so I think they are connected, if that makes sense.
Okay. So I think we have to start our last round of workshops, guys. You've done